Greetings all, welcome to our project, T-Tong, the Trustworthy and Open Network. We have chosen the on-chain data analytics track to showcase our work. We are Trusted Labs, a dedicated team focused on enhancing security and fairness on Tong blockchain through innovative solutions. To experience our latest developments, scan the QR code and try out our Taste of Humanity mini app on Telegram. Thank you. My name is Aaron, the speaker today. I'm part of Trusted Labs, the #1 AI-driven proof of humanity and on-chain reputation protocol. And Trusta, we apply AI to on-chain activity analysis and media reputation scoring, creating more trust and less friction in the Web3 world. Our Trusta Tong app is focused on the Telegram ecosystem, combining gamification with on-chain reputation to deliver an engaging and secure experience. Let's start by looking at the chart on the left, which shows the price trend of Nacoin, a very popular airdrop project on Tong blockchain. Please pay attention to the trend after the airdrop concluded in June. While there are many factors that can influence token prices, one undeniable aspect is whether the airdrop was distributed to real and valuable users. So our project aims to ensure fair participation, enhance network security, and protect user privacy. Our approach leverages on-chain data and AI-powered machine learning algorithms for detecting CBO accounts in a lightweight, interaction-free manner, making it one of the most advanced solutions. Additionally, we implement active verification through knowledge-based Q&A tests derived from our users' on-chain behavior for comprehensive identity checks. Through this method, we are able to identify and prevent CBO attacks and help build a truly trustworthy ecosystem for both project developers and users in Tong. The main takeaway here, we analyzed two popular airdrops on Tong blockchain, the Nacoin and Docs, and revealed that over 60% and 29% of participating accounts were identified as suspicious CBO accounts. This amounts to more than 1 million addresses flagged as potential CBO. Transition from our overall CBO analysis findings, let me introduce the first case study that shows one of the most common patterns that we detected. The initial observation was the coordinated transfer of gas fees to numerous addresses. This raised our suspicions as such behavior is not typical for real users. Here with the picture, we can see the main address distributing initial gas fees to multiple sub-addresses under its control, forming a star-like structure. This distribution typically took place within the same day with identical amounts sent as gas fee reserves. We then analyzed the on-chain behaviors of these addresses. What stood out was the high similarity across multiple dimensions, such as transaction frequency, active days, and the number of interacting addresses, etc. The next step these addresses took was sending the not airdrop tokens back to a main address, effectively pulling all the assets together. So based on all the evidence that we've discussed, we can confidently say that this is a typical CBO group in action. In this second case, we found a tree-structured pattern used for consolidating NOT tokens. A tree is basically the simplest connect way to link multiple addresses, make it an efficient way for bad actors to move or collect funds with minimal losses. Unlike straightforward structures like star-shaped distribution or chain-like transfers, a tree pattern is more hidden and harder to track. In this example, several addresses first gathered the NOT tokens and then funneled them into a central collection address. In the next case, we identify an aggregator address that collects airdrop tokens from multiple sub-addresses and then consolidated these funds by depositing them into a centralized exchange. By analyzing the memo information on-chain, we were able to trace transactions leading from the blockchain to the exchange, revealing this coordinated activity. Our CBO detection framework is fundamentally clustering-based, combining fund aggregation and behavior clustering. We utilize the Lovian algorithm for community detection within initial gas and JSON transfer graphs, a method proven effective in EVM-based airdrops like Arbitrum and Starnet. Additionally, we integrated KNN clustering, a classic machine learning algorithm that maps address behavior statistics into high-dimensional space, identifying similar groups based on distant metrics. In our analysis, tree structure and chain-like transfer patterns are flagged separately due to their efficiency. These structures represent minimal transition loops as they effectively connect multiple points within minimal pathways. Such patterns are highly effective for fund movement, indicating potential coordinated CBO activity. A unique aspect of Tong's on-chain data is the use of memo information, which significantly enhances our detection system. By analyzing memo data, we can pinpoint accounts controlled under the same sex user, uncovering fund consolidation patterns. This includes cases where multiple addresses use identical memo codes to deposit tokens into exchanges, or where the tokens are first collected by an aggregator address and then transferred collectively into a centralized exchange. Let's move on to our proactive approach, an interactive knowledge-based authentication system. This system creates a unique test of humanity by generating questions based on users' on-chain behavior. We let the users answer these questions, and our automatic backend evaluates their response to automatic their identity. What's more, this process is privacy-focused, ensuring minimal data collection compared to biometric methods and KYC process. Our verification isn't just about checking whether the answers are correct. We also evaluate the user's response time, answering pattern, and other factors to make a comprehensive judgment. This multi-dimensional approach stresses our detection against bots. Additionally, we leveraged AI models to introduce question variations, making it significantly more difficult for attackers to predict or game this system. Both methods ensure our KBA system remains robust and adaptive. Our project is designed to serve all users on Tong by providing essential data infrastructure services that can help builders save costs and boost efficiency with scenario-specific solutions. For users, our attestation service like Proof of Humanity and knowledge-based authentication offer unique opportunities to access rewards and rights, acting as an on-chain passport. We are also working on an omni-chain reputation system to attract more users from outside Tong. In terms of monetization, Trusted Labs has already shown the effectiveness of our humanity test system in the EVM space. We support top blockchain like Starnet and Celestia with SaaS-based airdrop services, and we offer analysis for platforms like Binance and Gitcoin. On the user side, we've launched on-chain attestation where individuals can mint proof of humanity for exclusive benefits. We are now replicating this success in the Tong ecosystem. Just last month, we had our first major commercial case, partnering with Lost Dogs on top team for anti-fraud solutions. To drive social and viral growth, we focus on key strategies that expand our reach and engagement. First, our collaborations with major blockchains significantly enhance our visibility, bringing more users into our certificating system. We also have a referral program that incentives users to invite others, promoting organic and community-driven growth. And lastly, our on-chain attestation service allows users to mint proof of humanity, giving them access to exclusive airdrops and rewards, which boost participation and keep users engaged. When comparing Teton to other solutions like centralized exchange KYC and World ID, our unique strengths stand out. While KYC relies on identity documents and World ID uses biometric data, Teton utilizes on-chain data as the identity source. This allows us to provide both active and passive authentication models. Furthermore, Teton addresses issues directly on-chain, ensuring solutions are seamlessly integrated with the blockchain ecosystem. Importantly, our approach minimizes privacy concerns comparing to KYC, which may have potential sensitive information issues, and the World ID, which relies on hardware and physical locations. This positions Teton as a more versatile and privacy-conscious solution. In addressing CBU detection on Tong blockchain, we encountered several significant challenges. One major issue was Tong's complex tree-like message structure, which is not as straightforward as EVM's simpler format and made decoding data difficult. Additionally, the limited availability of data providers complicated our data collection and analysis efforts. Despite these challenges, thanks to the dedicated efforts of Trusted Labs' data warehouse team, who provided well-decoded and comprehensive data, we were able to overcome these obstacles and carry out an efficient analysis. And that brings to the end of our introduction video. Thank you.